Hello, my name is Trupiano, and I am going to demonstrate our paper presentation, which is an exploration of the Firebase database engine by Google. This is for CSI5450 Database Systems 1. So what is Firebase? We're going to cover that. We're also going to cover the core feature sets of Firebase, the comparison of Firebase NoSQL versus your typical SQL relational database management system. We're going to cover some sample Firebase queries. We're also going to show the research spotlight that we looked at, which is a real-time communication network built with Firebase. We're also going to cover a sample database that we created using Firebase with reference from another website. And we are going to show our references. So what is Firebase? Firebase is a real-time database using the NoSQL backend that is hosted in the cloud. The data in Firebase is stored in a JSON format, and there is no use of tables. So that means you access the data using key value pairs, and those key value pairs are stored as objects. The values are stored as objects inside the database. You do not use any kind of formal querying for CRUD operations, such as select, insert, delete. There's no formal querying like that. The only kind of queries you'll use is using JavaScript methods. Data is synced in real time to each client that is connected to the database. It works from a numerous number of client interfaces, such as Android, iOS, Linux, etc. And it has the ability to use REST APIs for communication and initiation, which allows instant synchronization between client devices and the server side. Core feature sets. One of the core feature sets is storage. So it allows you to store large files in the cloud database easily with minimal network and latency overhead. It's easily accessible, remote storage for each client. It also provides authentication, which is the ability to integrate directly with identity providers through predefined official Google APIs. It provides messaging capabilities with real-time database functionality that allows projects to send and receive notifications and messages in real time. The data is stored and retrieved almost instantly. And finally, offline availability. So if someone loses their database connection to Firebase, there are SDKs integrated that provide utilization of the device's local cache, and then it stores the data to the cache and interacts with the cache data. And then when you restore your connection to the database, the synchronization starts again, and then your changes are synced to the online database, and everyone can see them. So Firebase versus SQL, what are the differences? So the first category is in data storage. So as we said before, data is stored as a JSON tree. In SQL, in a traditional RDBMS, this data is stored in a relational model, a table with rows and columns. The flexibility of the schema, Firebase employs a dynamic schema, which means the structure of the database is changeable at any time without a predefined structure for the data. So the data can be anything. You don't have to declare each column as a string, as a variable character. It can be any kind of data at any time. It doesn't matter. With traditional SQL, the database data cannot be added, updated, or deleted without resulting in access going offline temporarily, and the data must be declared as a specific type, as we see below. So the data in a NoSQL Firebase does not have to be of any kind of structure. With SQL, it has to be declared as a known type. In terms of data storage and retrieval, in Firebase, data is synchronized between the server and client continuously. In SQL, the data is retrieved, updated, inserted, or deleted based on a query provided. So the query is the initiator in a traditional SQL database. In Firebase, there's no real initiator. It's continuously synced. And finally, the supported languages. With Firebase, you have a little bit less options. You can interact with it with Java, JavaScript, and Swift. With SQL and a relational database management system, you have a bunch of options, including Java, PHP, Python, and your typical languages. So the structure of Firebase, as we said, it's a JSON structure. So we have your main database is going to be at the top, and then you have your different key value pairs. So we have a blog post, and then under the blog post, we have our IDs for each value set. And then, so under 0, the content for that author is whatever the default text I put in there as. I also made an individual user ID and the username for each person. So you can add as many of these as you want. You can take it away. If you change one thing, it's synchronized with all the clients, etc., etc. So this is basically the format of a Firebase database, a super simple JSON file. Querying, So like I said, there's no formal queries, but here's how you do it in JavaScript. So connecting to Firebase, you create a configuration variable and you define all of these items like your API key, your authentication domain, database URL, your project ID, storage bucket, message sender ID, and then you initialize the application with a JavaScript method in the Firebase library. Reading all data from a user's database. So this is you're importing your various objects that are required to perform this from your Firebase database library. You create a reference object, and then you're going to use the get method to read all the data from your JSON tree. This is the way to write a simple text string to Firebase. So if you already have the prerequisites done in the last slide, you get the instance of your current Firebase, you create a reference object, and then you just simply set the value of that reference object to be whatever you want. And in this case, it's hello, world. Uploading files. So Firebase allows you to upload images and large files easily. This is done in React. So we have a upload image to storage method where we create some storage objects and reference objects, and then we upload them using those objects. So for our research topic, we chose an article from IEEE where they focused in a Qatar hospital. They wanted to create a simulation training machine for an MCO, which is extracorporeal membrane oxygenation. And this simulation machine was created using Firebase as a research project. So the system connected simulation units for passing patient-related data parameters, ECMO blood circuit parameters, and related emergencies from the patient to the Firebase system in real time. One requirement satisfied by Firebase, it was the three systems that capture the above parameters must be continuously synchronized through a real-time database. So Firebase obviously satisfies that, as we said before, by providing that real-time communication between server and client with no disruption unless you have a disruption in the network. And it also satisfied another requirement they had of the trainer being able to control the system and parameters through a smartphone application. So with the built-in SDKs that Firebase provides, the trainer can easily change some patient data on the phone and it's instantly synchronized with the training simulation environment. And so in terms of communication between all of these system components, Firebase was justified as the database of choice for this project due to these following factors. It has low latency, as we discussed. It had to be adequately reliable and moderately uninterrupted in terms of the connection, and the instant change in control because of the database synchronization from a smartphone app. So the Firebase database is stored in a single JSON file, as we discussed. It allowed the team to have highly responsive data synchronization across all of the system components. The latency was in the range of mere milliseconds. This was proven in a test. So a single parameter was adjusted from the smartphone app, and the change was reflected in a Raspberry Pi, which is the server running a Python script. The results were the data retrieval was very consistent at 1,000 to 500 milliseconds in normal conditions. So here is a diagram of kind of what was happening. So the system is divided into three sections: patient, instructor, and cloud. According to the paper, the instructor can initiate a data change through a remote scenario management smartphone application. The changes are stored into Firebase and directly synchronized with the patient side. The EMCO unit synchronizes the database changes into the system locally, then translates them into meaningful instructions for the trainees. Each system in this diagram has the ability to perform CRUD operations on the database at any time, and all changes are directly synced to all parties, with no need to inform all other units when changes have been made. And each unit can read the changes and act accordingly in real time due to that real-time synchronization inherent to Firebase. So in summary, using the NoSQL properties inherent to Firebase, it was chosen as a strong candidate for the simulator due to the low latency and instant syncing properties inherent to the database. Since Firebase is widely compatible with many devices and interfaces such as Android, iOS, and even Arduino, it made sense as the database of choice for EMCO due to a limited time frame for development. And then communication between devices is coded using predefined SDKs as opposed to coding all of that low-level code from scratch. Okay, we're going to quickly demonstrate our sample Firebase. So here is our Firebase backend. So inside Firebase, it gives you a very easy guide as to how many reads and writes and hits your database is taking. So if you go into the real-time database, we see that we have our database structure. And this is a simple structure. It's a JSON file that you can easily import. And here is the import file that we have. So we created a JSON file with the blog posts being the main key. And then here are the value sets. So we have a user ID, a username, and the content. We designed this to be a blog author sample database. So you have the author, you have their author ID, if you want to call it that, and then their bio. So this is the sample database, and this is referenced from a Firebase sample database that was already done, and that was via softauthor.com. So in here, you can actually edit your database through the GUI, but it's much easier to just import a JSON file as we showed you before. So the result is this interface. It's a very simple interface, but you can, here it generates the list of authors. It generates the list of authors based on the creation of references to the Firebase object and your JSON list. So here we're generating list items for each value set in the Firebase database. So for each value set I got this value set, which is the username Sal Trupiano, user ID of 123, and here's the content. So for each value set, it's going to generate a list item that you can have in the web page. So it's generating the HTML as it reads through Firebase. And then this click user function hides all of that content that we generated under each name. So again, when we're in the sample database, when I click on a name, it calls the click user function, which gets the attributes and the references, and then sets the inner HTML in with a paragraph element for each item in the database. So it gets the content, the user ID, and the username. We'd like to thank you very much for viewing our presentation on the exploration of the Firebase database system by Google. If you have any questions, you can email either me, Sal Trupiano, or Richard Frost. Thank you very much, and have a great day.